Hi everyone. For today's lesson, we are going to learn about how to graph quadratic functions in standard form. I have a warm-up for you, and I would like you to please simplify each of these easy expressions to simplify. Please pause the video and do that, and when you have an answer, please restart the video and we will see how well you did. All right, whenever you are simplifying expressions with parentheses, you have to remember that you are squaring the parenthesis. And what that means is that -3 is being multiplied by -3. If you put -3 squared into your calculator, you're going to end up with -9. But what it really means is -3 times -3, which is a +9. So what I need you to remember is that whenever you are substituting values into a formula that deals with a square, you need to make sure that you use those parentheses and remember that it means that you're multiplying that number by itself twice. So -2 times -2 is +4. -1 times -1 is +1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So hopefully you got all of those values correct, because what we just created here is essentially the table for the parent function of a quadratic. And that's what this lesson is all about. We're going to be analyzing quadratic functions, but this time it's going to be in standard form. There are 3 forms that you're going to learn about: standard form, intercept form, and vertex form. So our learning objectives for today is for you to be able to say, I can graph a quadratic function in standard form. I can determine whether a parabola is pointing up or down. I can determine the line of symmetry, the vertex, and the y-intercept, among other points, from a quadratic function in standard form. Now, a quadratic function in standard form can be written as y is equal to ax squared plus bx plus c. In this form, you will not see parentheses. The other forms, vertex form and intercept form, you will see parentheses, and we'll analyze those at another time. The graph of a quadratic function is a parabola, and that is a U-shaped graph. So when we talked about absolute values, that was a V-shaped graph, where it was very, very rigid at the bottom. For parabolas, I'm going to be looking for it to be a smooth curve at the bottom or at the top of your parabola. It should look like the letter U. Let's go ahead and analyze the parent function for quadratics. Now, the parent function is your simplest form of that function, and that is written in the form of y equals x squared, or f of x is equal to x squared. It's the simplest form because we're not multiplying by any other numbers other than 1. We're not adding anything on the outside. It's the most basic form of that function. And the table of values for the parent function is essentially our warm-up. If we were to let x equal -3, -2, -1, 0, 1, 2, and 3, our outputs is where we plug in -3 into our parent function. -3 squared is 9. So our outputs is essentially our warm-up. 9, 4, 1, 0, 1, 4, 9. This table is something that I need you to know and study. So please make sure that you feel very comfortable with identifying the parent function ordered pairs. Now, what you see here is the graph of a parent function, and there's a few things that I need you to know. First of all, right here is the vertex. The vertex is the ordered pair 0, 0. It is going to be your most minimum point. Up here, it's pointing to a line, and this line is your reflection line. We learned a lot about reflection lines when we were in geometry. This is your reflection line, also known as your line of symmetry. Your line of symmetry is always going to be a dashed vertical line. So let me use a different color so you can see that. It's always going to be a dashed vertical line, and every single one of your graphs are going to need a line of symmetry. So this is your line of symmetry, also known as your axis of symmetry. Both of these terms are used interchangeably: axis of symmetry, line of symmetry. So if you ever see in directions, identify your AOS or identify your LOS, they mean the exact same thing. It's your reflection point. And what we have here is a very symmetric graph where we can see that the points on one side have a reflective point on the other side. So being able to identify reflection points is going to be very important in this chapter. What you should see in the table whenever you're analyzing a table is that you should see symmetry amongst the y values around your vertex. And that indicates the symmetry of our graph. This line of symmetry is always going to be a dashed and vertical line. And because it's a vertical line, that means that we can write an equation for it. It's going to be a Buck's equation, vertical line, undefined slope, x equals a number. And what x is going to equal is the opposite of b over 2a. So the way that we read this, negative b, that's going to be the opposite of b, the opposite sign of b. So it's the opposite of b over 2a. This is something that I need you to study. The other thing I want to make sure that you understand is domain. Domain represents all of the x values that the function touches. So it's all the x values the function touches. And in this case, because we have an arrow pointing to the left and an arrow pointing to the right, there doesn't exist an x value that the function can't do, which means that there doesn't exist a number that you can't square. So, therefore, your domain is going to be all real numbers. And there is a symbol for all real numbers. It is two lines and then an R coming off of the second line. And that's a symbol that you're going to see a lot, all real numbers. Range represents all of the y values the function touches. And it doesn't cross all of the y values in this case. We have a minimum point. Negative y values are not a part of this graph. So in this case, your range is going to be all values of y greater than or equal to 0. This 0 comes from the y part of the vertex. And so it's going to be important for you to recognize and know how to identify the range, because identifying domain and range is going to be a part of graphing. So here are some properties that I need you to be aware of when it comes to a graph in standard form. First of all, a parabola can either open up or it can open down, and it's going to be based on your a value. Now, if your a value is greater than 0, that means that it's a positive number. And if it's a positive number, then that means that it opens up. If a is less than 0, that means that it's a negative number. And if you see that a is a negative number, then your parabola is going to open down. Now, your parabola is going to can be the same width as the parent function, skinnier, which we call a stretch, or it'll be wider, or shrink. We call that vertical stretch and vertical shrink. You'll have a vertical stretch if the absolute value of a is greater than 1, like 1.5, 2, 3, 4. And you'll have a wider absolute value if the absolute value, you'll have a wider graph if the absolute value of a is less than 1. And so you'll likely see a fraction or a decimal. A fraction that is smaller than 1. Now, what happens if the absolute value of a is equal to 1? If you see that the absolute value of a is equal to 1, that means that it has the same width as the parent function. And what that means is that there's going to be no stretch or shrink. So there's going to be no stretch and no shrink. Once again, your axis of symmetry or your line of symmetry is going to be the equation x is equal to the opposite of b over 2a, remembering that up here means the opposite of b. And it's going to be a line that needs to be dashed and vertical. So it's a dashed and vertical line. Your vertex will have the x coordinate of opposite of B over 2A because your line of symmetry always crosses through your vertex. And so what you'll do to find your y value is you'll substitute this x value from the line of symmetry and solve for y. So your vertex is going to be the ordered pair, the opposite of B over 2A, comma y. And every single one of our graphs has a y-intercept, and that y-intercept is located at 0c. So whatever your c value is, that's always going to represent what your y-intercept is. And you can see that in both of these examples. All right, let's go ahead and move the page, or flip the page. We're going to graph two parabolas. And what I'm going to be looking for is for you to be able to identify 5 key points. 5 key points. You only need 3 to graph. But it's in your best interest to graph all 5. But I'm going to say but. Graph all 5 if you can, if possible. Okay, so what are those points? Well, let's go through these steps working with this first example. It says, determine whether the parabola, step 1, determine whether the parabola opens up or down. Well, that's going to be based on our a value. So what I would recommend doing at the very beginning is identifying that a is equal to 2, b is equal to 6, and c is equal to 3, because we're going to be working with all of these values. So step number 1, since a is the number 2, so a is equal to a positive number, that means that it's going to open up. And so our parabola is going to be looking like a U that's smiling at us. Step number 2, it says find and draw the line of symmetry. So remember that your line of symmetry is x equals the opposite of b over 2a. That is the third time I've written this because it is so important for you to know this formula. So what's the opposite of b? The opposite of 6 is negative 6. So this is my line of symmetry, and I'm going to write x is equal to the opposite of b over 2 times a, which is 2. And I'm going to use parentheses whenever I substitute. So then I have negative 6 over 4, and this is equal to negative 3 halves, or negative 1.5. So my line of symmetry is x equals negative 1.5. I strongly recommend that you rewrite this as an x equals because it's representing a line. This is a line of symmetry. So on my graph, I'm going to go to where x is equal to negative 1.5, and I'm going to draw a vertical and dashed line going through negative 1.5. If you want to have a highlighter or something with you, that's fine, but you don't have to. Step number 3. It says, find and plot the vertex. Well, we already know half of our vertex. We already know that the x part of our vertex is negative 1.5. We just don't know what the y part is. So that's what we need to find. And so the best approach for finding it is to substitute negative 1.5 directly into the function. So that's going to be 2 times negative 1.5 squared plus 6 times negative 1.5 plus 3. And when you put this entire expression into your calculator, parentheses and all, make sure you have the parentheses, you'll end up with negative 1.5 as well. So I'm going to go to where negative 1.5, negative 1.5 is, and I'm going to plot my vertex. Cool, I am done with step number 3. Now I'm on to step number 4. Step number 4, I need to find the y-intercept and then reflect the point, RPT, over the line of symmetry. So my y-intercept is located at 0c, and since my c value is 3, that's going to be located at 0, 3. So I'm going to go to where 0, 3 is, 1, 2, 3, and I'm going to plot my y-intercept. Now I need to come up with an RPT, a reflection point, and this ordered pair is 1.5 units away from the line of symmetry. So I'm going to count 1.5 units on the other side and identify what this RPT is. And it looks like it's located at negative 1, negative 2, negative 3, 1, 2, 3. Negative 3, 3 is my reflection point. Step number 5 it says find one other point called the OPT. And what that means is that you're going to let x equal any number that you want. Now, whatever number that you want needs to be a number that has not already been used. So what I mean by that is you can't let x equal 0. You can't let x equal -3, and you can't let x equal -1.5 because all of these x values have already been chosen or already been used. So you need to come up with a different number, like maybe the number 1. That's an easy small number. So what I'm going to do is I'm going to let x equal 1, and I'm going to write y is equal to 2 times 1 squared plus 6 times 1 plus 3. So 2 times 1 squared, that's 2. 2 plus 6 is 8. 8 plus 3 is 11. So 111. So I'm going to go to where 111 is. And that's going to be all the way up here. And now I'm going to count how many units it is away from the line of symmetry and count the same numbers on the other side. So I'm going to go 1, 2, and a half. So I'm going to count a half, 1 and a half, 2 and a half. And it looks like that ordered pair is located at 411. So that is the reflection point of my OPT. So my reflection point is going to be located at -411. I now have my 5 points. So now I just need to go to step 6, which is draw a small curve through the plotted points with arrows at both ends. So I'm going to draw a smooth curve going through my points, making it look as U-shaped as possible. And there's my parabola. Next, we need to identify the domain and range. So your domain is always going to be all real numbers, and your range is always based on the y part of your vertex. And the y part of our vertex is located at -1,5. And my parabola is pointing up. So I'm going to have my range be y is greater than or equal to -1.5. If my parabola was pointing down, I would have y is less than or equal to -1.5. And that is your answer. When you take your test, I'm going to have blanks for all of these spots, and you'll need to fill out all of this information to the very best of your ability using these steps. So this is something that I need you to study. So I just want to note up here that to identify your range, remember this is the y part of your vertex. And it's going to be y is greater than or equal to if it's pointing up, and y is less than or equal to if it's pointing down. So I want you to go ahead and pause the video, and please go ahead and try number 3 on your own. And when you have an answer, please go ahead and restart the video, and we'll see how well you did. All right, for number 3, we need to identify our A, B, and C. So my A value is equal to 1, my B value is equal to -2, and my C value is equal to -1. So the first thing we need to do is determine whether it's pointing up or down. And in this case, because my A value is positive, it's going to be pointing up. So I should have a parabola that's pointing up. Step number 2, I need to identify my line of symmetry. And remember, that's the x is equal to the opposite of b over 2a. And the opposite of -2 is +2, divided by 2 times 1. So this is going to be equal to 2 over 2, which is 1. So x equals 1 is my line of symmetry. And I'm going to go to where x is equal to 1, and I'm going to draw a vertical dashed line. Next, I already know half of my vertex, which is step number 3. My vertex is located at 1 comma something, and so I need to substitute that 1 into my function. And I'm going to write y is equal to 1 squared minus 2 times 1 minus 1. Always use parentheses whenever you're substituting, and you'll end up with -2. So I'm going to go to where 1, -2 is, and I'm going to plot a point, and that's my vertex. Step number 4, I need to identify my y-intercept. And my y-intercept is located at 0, comma, c. And my c value is -1. So I'm going to go to where 0, -1 is. And I'm going to plot a point. And now I need to identify an RPT. That's my reflection point. So 0, -1 is 1 unit away from the line of symmetry. So if I count 1 unit on the other side, that's located at 2, -1. And that's my reflection point. Step number 5, I need to come up with an OPT. That means that I need to let x equal a number outside of what I've already used. So 1 I cannot use, 0 I cannot use, 2 I cannot use, so I'm going to let x equal 3. Just keeping this easy. So I'm going to write y is equal to 3 squared minus 2 times 3 minus 1. And when I plug that into my calculator, I end up with 2. So 3, 2. So I'm going to go over to 3 and up to 2, and I'm going to plot a point. Now this point is 2 units away from my line of symmetry, so I'm going to count 2 units on the other side. And that point is located at -1, 2. So that's called my RPT. I have my 5 points. Step number 6 is simply just to draw a smooth curve going through all of my points. Step number 7 is we need to identify our domain and range, which domain is always going to be all real numbers because we have an arrow pointing to the left and an arrow pointing to the right. My range is going to be a little bit different. My range is always going to be based on the y part of my vertex. Since it's pointing up, it's going to be a greater than or equal to, and the y part of my vertex is -2. So my range is y is greater than or equal to -2. And that is the end of this lesson. If you have any questions over graphing functions in standard form, please make sure that you email me. Otherwise, I hope you have a wonderful day.